Okay, in this video we're going to talk about converting from different types of structures we can have. So looking at the screen, I've just included the molecular formula, and that's shown here. We have two examples. The first example, we're starting with C5H12. And obviously with a molecular formula we don't get any structural information, so that's not very useful for us. So, but it does provide the number of, obviously, atoms we have in our structures. So we'll really start with the condensed structure first. And the condensed structure is obviously just that, a condensed structure which shows or gives information about the connectivity between the different atoms in the molecule. So these are two examples of the same condensed structure, so kind of two different ways of writing the same thing. So you can either write the top example or the bottom example, and they're kind of done both ways in different textbooks. But let's just kind of work with this top example first here. So what we're going to do is really talk about how we convert from the condensed structure to the Kakhiel structure or the structural formula. A lot of textbooks use the condensed structure because it takes up less space. It's easier to fit structures on and draw these in textbooks. So a lot of textbooks will use the condensed structures. But when we're thinking about structures, we really want to get a little more information on what they look like in 3D, and the Kakhiel structure and the bond line structure are really better at doing that. So let's first talk about converting from this condensed structure to the Kakhiel structure. So in the condensed structure, what we see is we start off with a methyl group here. Okay, that's a CH3. And what we have to recognize or remember is that hydrogen makes one bond while carbon makes four. So the key here is really remembering that the connectivity is from the carbon atom to the carbon atom. And that's what we see here. So here's our first carbon atom that has three hydrogens attached to it, and there's that bond really connecting those two carbon atoms. The next thing we see is this CH2, I'm circling in red, and that's obviously connected to the next carbon, which I will circle in blue. Okay, so now we have a CH2 in red, shown here, and the key is to remember that the hydrogens can only form one bond, so really the carbon atoms are what are attached. So this carbon in red is bound to this CH in blue. So the carbon in red here is bound to the CH in blue. So in blue, in the condensed structure, we only see that we have a CH. So we have to remember that carbon is always going to make four bonds, so we're missing two more bonds. We have the structure from the carbon in red to the carbon in blue. The carbon in blue has one H, so carbon has to have two more bonds, and that's where these two CH3s come in. So if you see that 2, in this case it means both of these methyls are both connected to that carbon in blue. And here they are here. So here is our CH3 in green, our CH3 in green, and they're both connected to that carbon in blue. So that's how we go from that condensed structure to the Kakhiel structure. Now I want to discuss how we go from the Kakhiel structure to the bond line structure. And the bond line or skeletal structure is really the most commonly used structure, and we make a couple assumptions. The problem with the Kakhiel structure is it simply takes too long to draw that. It's not necessary to draw all of the carbon atoms and all of the hydrogen atoms. So if we scroll down, we can look at kind of these bond line structure rules, and let's go through these. The first one states that carbon atoms usually aren't shown. So in bond line skeletal structures, we're not going to show carbons. A carbon is assumed to be at the intersection of two lines, and two lines represent a bond. So lines represent a bond. The next thing we see is that hydrogen atoms bound to carbon atoms are usually not shown. Carbon has a valence of 4, so we mentally supply the correct number of hydrogen atoms. and that's important. We have to remember carbon has a valence of 4, so we add in the extra hydrogen atoms, so carbon is making 4 bonds. And the last thing is pretty important. Atoms other than carbon and hydrogen are always shown. If you have an oxygen or nitrogen or sulfur, those are always shown. Because if you don't show it, you assume that it's carbon. And the last thing, which is really important, is about the hydrogen atoms. Anytime you have a hydrogen atom that is not connected to a carbon, you always show it. So if H is connected to C, you don't have to show it, but if it's connected to O or S or N, you do have to show those. All right, so those are the rules that we want to look at. And let's look at how we convert this. So notice we started with this methyl group on the left. That's signified by this carbon here. All right, so that dot, the end of the line, represents a carbon atom. So we remember that carbon atom always makes 4 bonds. So what that means is coming off this carbon, we have 3 hydrogens to give that carbon 4 bonds. Okay, but we don't show that. All right, so we don't have to show that, but that's what it signifies. Next in red we have a CH2. That is this carbon here. Okay, and what we remember is, again, not shown are those 2 hydrogens. Okay, again, we don't have to show those, and we don't. Alright, so we can erase those. Followed by the carbon in blue with 1 H. So here's the carbon in blue, and I'm just going to add in that hydrogen. Alright, so that's a hydrogen. Sorry, the drawing's a little sloppy. And again, we don't have to show that. We can erase that because it's not shown. And then the 2 methyl groups in orange, here and here. Okay, and again, both of those carbons at the end of the line represent a carbon atom, and that is each of those are connected to 3 hydrogens. So to summarize, the first carbon is black, represent and has a bond to 3 hydrogens. Then we have the carbon that is red, and that's connected to 2 hydrogens not shown. And then we have that's connected to the carbon that's blue, again 1 hydrogen, and then the 2 methyl groups, the 2 CH3s at the end. And that's how we convert from the bond line skeletal structure. So again, we're not showing any carbons. Carbons are represented at the ends of each line. So each line represents a bond of 2 electrons. What's on the other end of that line is a carbon atom. If nothing is shown there, this in black, in red, blue, and green are all carbon atoms. So we have 1, 2, 3, 4, 5 carbon atoms. Great. Alright, so now let's look at our second example here. This one, now we add some heteroatoms, some oxygens in this molecule. There's the molecular formula. Again, molecular formula can't give us any information about the structure, so we really have to start with a condensed structure. And what we see here is a little more complicated example, but let's just go through this again. So now I have 2 CH3 groups. So I have 2 CH3 groups, and I have to look at what they're next connected to. Both of these CH3 groups are connected to that following carbon, and they're shown here. So here's 1 CH3, another CH3, and they're connected to the second carbon. That second carbon is a CH. Here's the CH, okay, which makes sense. That CH is connected to the 2 methyls in black, and then something else moving forward. So now what's next is I have 2 CH2s. So what that means is now I have 2 CH2s. Those are connected to each other. So the carbon in red is connected to 1 CH2, and then that CH2 is connected to another CH2. So normally when you have CH2s, it has to have connectivity on the left side and the right side. So there's 2 of those. If we look at the example that we started with in black, I had 2 CH3s. They're connected to the same carbon. But the CH2s that are in blue are actually connected to each other. They're not both connected to the red carbon. They're sequential. So 1 CH2 and then another CH2. After that, we get to a CO. Okay, and this is an interesting case. We have a CO. So we know that we have a carbon connected to that blue CH2, and then that carbon is going to be connected to what's next, which is another CH2. So thinking about that, we have to realize that this carbon in green here is connected back to the one in blue and the next one, so that leaves 2 open spots for carbon to form 4 bonds. And that's what we see here is this carbonyl is actually connected, this carbon-oxygen bond is a double bond. So the oxygen is connected to the carbon double O. The oxygen is connected by a double bond to the carbon. So that CO means this O is connected to the carbon by a double bond. And that now the carbon in green has 4 bonds. So moving forward, we see we have 2 CH2s. Again, there's 2 of those. So I have a CH2 followed by another CH2. They're connected. The first CH2 is connected to the green carbon. The second CH2 is connected to the other CH2. And that leaves us with an OH. So the second CH2 group is connected to an OH as shown here. Okay, so that's how we convert from this condensed structure to the Kakhiel structure. And when you first start working on these examples, it's probably easiest to go from the condensed structure to the Kakhiel structure first. Now what we're going to do is talk about going from the Kakhiel structure to the bond line structure. Okay, and again in this bond line structure, not going to show any carbons. Hydrogens shown to carbons aren't shown. Every other atom is shown. Oxygens are shown, and a hydrogen connected to oxygen is also shown. So again, looking at this, we start with a line. So we have a line here. So this is our first CH3, and that's a CH3. So just to remind you, it means that this is a carbon atom connected to 3 hydrogens that we don't show. Same situation on top. Okay, those are both CH3 groups. Okay, so let's just circle these in black. Those are my CH3s. What's next is my CH group. That's in red. Again, if you notice that carbon that I just circled in red only has 3 bonds. What's the 4th bond? It's that carbon to H. So there's a C to H bond right there. But again, we don't show it in this structure. After that, we have 2 CH2 groups. H, 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 H. Okay, and again, those are normally not shown here, so we can erase them, but we know they're there. We know that those carbon atoms in blue have 2 hydrogens each. So let's just circle that. CH2 in blue, CH2 in blue. Follow that, we have our carbonyl. Again, I'm not drawing the carbon, I am drawing the oxygen, and I need to show it's a double bond. So it's a C double bond to O. After that, again, we have 2 CH2 groups, CH2, CH2. So each of these I just circled in black only show 2 connectivities. The other 2 bonds are connected to hydrogens. And then finally we get to our OH. So in the skeletal structure, we normally don't show the bond between the OH. So here's the bond. We don't have to show that. In this case, we don't have to show it. So what this really means is that I have a carbon bond. So this is a carbon bound to an O, right? The end of the line, I'm showing an actual O here. All right? This is an O. This is an O. If there's nothing there, then it would be a carbon. But when I draw an atom there, it is the oxygen atom. So if you remember looking at the beginning, we had in our formula 8 carbons. Let's just count those real quick. Let's just erase this, give us a little more space. And then we'll go ahead and count these carbons. Okay, so here's carbon 1, 2, those are those 2 methyls in black. There's carbon 3, 1H attached to it. Carbon 4 and 5, those are both CH2s, they each have 2 CHs. Here's our carbon 6. And then we have 2 more, CH2, 7 and 8. And then finally we end with our OH. So if you look at your formula, we have 8 carbons, we have 2 oxygens, top there, and then if you count all the hydrogens that aren't shown in the bond line structure, you will get exactly 16 hydrogens, and that can be really shown in the Kakhiel structure. Okay, so hopefully this video has kind of helped you understand how to go from a condensed structure to a Kakhiel structure to a bond line structure. In class and problem sets and exams, we will be primarily using this bond line structure. Alright, so it's important that you're comfortable with drawing these bond line structures. Okay, so let's now scroll down and take a look at your homework. So what we want to do here is, for class, I want you to draw the correct bond line structures for the following compounds. Example 1 and example 2. The first time you do this, it'll probably be most useful for you to draw the intermediate Kakhiel structure first, and then draw the bond line structure, and please turn that into class on Wednesday.